Hello all, welcome back. So let us continue our discussion on the Arduino. So we have talked about a bit that we have ADC pins on Arduino Uno, right? And we also said there are three different voltage reference options that can be provided to the Arduino, ADC of Arduino basically. So one could be 1.1 volt, which is internal reference. One could be A reference, which is a pin on the Arduino Uno where you can give an external supply to act as reference, or by default the V reference of Arduino is connected to AVCC as shown here. So if you don't configure your reference for either ARF or 1.1, the default V reference voltage is AVCC, which is the supply voltage to the Arduino, which is 5 volts basically. So this meant um, we can read analog inputs till a range of 5 volts. Now that range, what we are calling, is called a full scale voltage. So a full scale voltage is nothing but the maximum voltage up to which a particular microcontroller can read over its ADC port, right? So now we are saying the full scale voltage is 5 volts, and then the resolution is 10 bit. That meant considering these two inputs, we are saying that we can read any analog voltage from 0 to 5 volts, right? But there is a minimal incremental voltage which can be read. That means, example, if a microcontroller reads 0 volts now, there should be a minimal incremental voltage which can only be read considering the resolution. So that minimal voltage is nothing but 4.8 volts. So 2.7 millivolts of input is still treated as 0 by Arduino Uno. So this 4.8 comes up by having a ratio of Vref by 2 to 2 to the power of 10 minus 1. 10 is nothing but the resolution here. So this gives the minimal incremental voltage which can be read by this microcontroller. So this is a very, very important calculation. So when we connect external sensors and we provide inputs, it is important that we know this voltage, because this gives us what kind of sensors we can connect, whether a particular sensor input incremental inputs from a particular sensor can be read by Arduino Uno or not. And then we said that there are three different references that can be given to the ADC, right? So these references can be selected in the program. So by default, we mentioned that it is AVCC. If you want to change to ARF or internal 1.1 volt, we have an inbuilt function in the Arduino library which is called the analog reference. So if you give analog reference of internal, which means it takes internal reference voltage of 1.1 volt. So in that case, your full scale voltage is restricted to 1.1 volt. If you say analog reference of external, that means you can see here external is ARF, which takes ARF based on the voltage that we supply to the ARF pin of the microcontroller. So a very, very important point. So now you can see we started looking into the inbuilt functions of the Arduino. So once we write the program, we have to know these default functions so that we can start our program. And then in a microcontroller, for any interface internally, we mentioned that the functionality entirely depends on the clock. Okay, so because these are all digital, right? So it entirely works based on the clock input. So ADC also requires a clock, but this clock is not a clock frequency which is equivalent to the system clock of the Arduino Uno. So we mentioned that the external clock, the crystal that you connect here can go up to 16 megahertz, right? That's what is connected to the 80 mega 328p. But we need not operate the ADC at that frequency. So generally, we operate it at 100 kilohertz kind of frequencies. Now, this means we need to generate that particular frequency, that particular clock to the ADC, so that it can operate at that lower frequency. So it is clear, right? So we have to somehow scale down the voltage before using it. So to scale down the voltage, there is something called prescaler inside the microcontroller. So this is just not related to ADC. For any other peripheral inside the microcontroller, if you want to generate clock to that peripheral, a lower clock to that peripheral, you have prescalers. What prescaler does is it divides the clock. You can see in the image here, it divides the clock at a specific fractions, like example clock by 2, clock by 4, clock by 8, and then generates a lower clock such that this can be used as a ADC clock reference. So that is how we generate the ADC clock. So this settings, how we need to set the registers of ADC, the designers need to know. And then once the ADC input is provided, and we write a program to convert that analog input to a digital input inside. So the result of that particular ADC will be stored in combination of two registers, which is called ADCH and ADCL. So ADCL is the lower byte register, and ADCH is called upper byte register. That means the total conversion result will be a 16-bit value, which is stored in two 8-bit stored as two 8-bit values. So in your program, when once the conversion is done from the microcontroller, if you want to read the result, these are the two registers that need to be read. And then let us assume I just gave a minimal voltage of 4.8 millivolt, what we said 4.8 or 10 millivolts. So that means this is a very, very small value, right? If you represent it as a 16 bit, it would be 0, 0, 1 or 1, 0 or whatever based on the value. So whether that just a result of 1, 0, will it get stored in ADCH or ADCL? That's a very, very important point. We need to know that correctly so that we can exactly convert that register value into the actual value to find out what is the analog voltage. So for that, the result inside these ADC registers can be saved as either right justified or left justified. So so if basically the result is stored as a right adjusted, what it means is the 0, 1 or 1, 0 what we talk will be towards ADC, the first bit of ADCL. So this is another very, very important thing. So we have ADC registers inside where you can configure it as the result storage can be either right adjusted or left adjusted. So that's another important point we need to know about reading the ADC. So hope we gave a good information on ADC. Please post your comments. Please let us know if you have any comments. Thank you.